Cross correlation function. Cross correlation is the relation between two different signals. I'll explain here. It is cross correlation is denoted with Rxy of tau is equal E of x of t and y of t or t plus tau. We can write it. I will explain how we can write. So average of two different signals is called, that is cross correlation, or the relation between two different signals, that is x of t and y of t plus tau. So I will explain here. This is the x of t I am assuming here. X of t, just assumption. This is the x of t and the time is in 2025. This is x of t. It is having, that is 2 volts. And this is also one more image or one more signal I am assuming here. One more signal I am assuming. Here also it is also having that is same. It is also having that is same 2 volts here. And this is in 2026. Now it is x of t is having 2 volts and y of t is also having 2 volts. What is an average? Two different signals. Average, just assumption, just like real numbers I am calculating here. That is 2 plus 2 by 2 is equal 4 by 2 is equal 2 is an average. So this is an cross correlation. Just assume that, or else the relation between two different signals is called as cross correlation. If you go for autocorrelation, uh, as I said, it is x of t and it is also having 2 volts here, and this also x of t plus tau, same signal only but time only different. I am assuming it is in 2026 and this is in 2025. So means again the average of two signals is, just assume this. I am assuming this is x of t plus tau is having 3 volts. Then what is the signal? 2 plus 3 by 2 equal 5 by 2 equal 2.5 is an average. This is the autocorrelation. The relation between same signal with different time slots is called autocorrelation. The relation between two different signals is called, that is autocorrelation. Finally, the average of two signals is called the autocorrelation or else the cross correlation. And coming to the proof, I will explain here. We can see this. The average of, we are discussing about cross correlation. So denoted with r xy of tau. If you go for autocorrelation, it is rxx of tau. So here the average of two signals, as you discussed now, average of two different signals. Average means expectation, x of t multiplied with y of t plus tau. Y of t plus tau here. So here you can write it as when this is the final equation. We need to prove this. This is the cross correlation function. We need to prove this. So therefore, proof rxy of tau is equal, or else average of two signals. I will explain here. E of x of t. I am taking two different signals, x of t1 times also different y of t2. So this is average. Average means integration of x of t1 y of t2 or f of x, y, t1 comma t2 dx dy dy. Now we can say this, if it is stationary random process you can write it as, that is if it is stationary, so we can write it as, that is t1 equal t1 plus delta, and similarly t2 equal t2 plus delta, we can write it. Substitute in the above equation, you can write it as minus infinite to plus infinite x of t1 and y of t2 f of x, y, t1 plus delta, t2 plus delta, that is dx and dy. Now is assuming let t delta equal minus t1. Substitute in here, in the place of delta need to substitute, that is, now we can write it as x of t, or xy also you can write it xy instead of x of t, and t1 minus t1 xy, t1 minus t1 comma t2 minus t1, t2 minus t1 dx1 dxy dx dy. Now it will become 0, t1 minus t1, and he is assuming t2 minus t1 is equal to tau. Again let, I am assuming let t1 t2 minus t1 t2 minus t1 equal to tau, then t2 equal t1 plus tau. Substitute this equation in above equation, then you can write it as e of x of t1, or x of t1, y of t2 means t1 plus tau, t1 plus tau is equal minus infinite to plus infinite xy and f of xy 0, t2 minus t2, in the place of t2 minus t2 can be written as tau, because t2 minus t tau equal to tau. Substitute in this of dx dy, I am assuming that is d tau, function of d tau. So now we can say this is then average of two signals xy into f of xy dx dy, or d tau, and function of tau. So therefore this can be written as in the form of or x y of average of two signals, or x y of tau. So this also can be written as x of t into y of t plus tau. Instead of t1, you can, here I am assuming t1 equal t, t1 equal to t. So this is the cross correlation, the relation between two complete different signals, and this is x of t assuming, and this is x of t plus tau. This is in 2025, the time, assuming this is in 2026. That is, I am assuming y of t plus tau, y of t plus tau. So this is the cross correlation.